Hi, Chris here, just giving you a bit of work through this really long question, okay? So a surveyor is standing at the top of a building. So here's my surveyor, the little person sitting right there. And it says she measures an angle of depression of the base of the next building is 30 degrees. So depression is going down from looking horizontal, so looking straight across, and then looking down is depression of 30 degrees. And then it says, then she measures the angle of elevation to the top of the building as 20 degrees. So that's going up this way. So that's our angle of elevation. There's 70 feet between the two, so that's going from here to here. And then they asked how tall are the two buildings. So I need to know this guy, and I need to know this guy is part 2. Okay, so we're going to try and draw these different triangles and do a little bit at a time. So I've stolen the same diagram as from here, from the content page, and drawn just worrying about the triangles. But again, our focus is going to be, we got to find this guy, oops, this guy, and we need to find this total distance. Okay, but we should note that the side 1 from A to B is the same as the side from D to C, so that can help us out. So let's focus on the bottom triangle for a minute, because we're going to try and find this length AB. And we know that this is a right angle up here. So we could find that angle A, so in triangle ABC, we know that angle A plus 30 degrees should equal 90 degrees. Okay, that's this right angle here. So we know angle A must equal 60 degrees. And then even though we've got the diagram on the left, I'm going to redraw that triangle just so I can focus in on what I'm looking at. So I've got a right angle here, I've got a 60 degrees, I've got a 70 feet here, and this is really what I want to know is this side. I'm going to relabel it A, B, and C. And I want to know this side here, okay, the unknown. Because it's a right angle triangle, I can choose what set of formulas. I can use SOHCAHTOA. So I'm going to label my triangle, and the first thing I'm going to label is, there's the hypotenuse, really important. The second one is I'm going to say this is the angle I'm thinking about, which makes this side over here the opposite, and this side the adjacent. I'm going to write down my 3 sets of formulas. Sine theta equals opposite over hypotenuse. Cos theta equals adjacent over hypotenuse. And tan theta equals opposite over adjacent. Which of the 3 formulas should we use? I'm going to identify that I know the angle and I know the opposite side, and I'd like to know the adjacent side. So I've identified it has to be this formula is the one I want to use. So I've got tan theta equals opposite over adjacent. Tan of 60 degrees equals the opposite 70. The adjacent is unknown, so we can call that A, if you like. Okay, adjacent or A. And then we need to solve, what do we do next? Since we want A on its own, we're going to get it out of the basement, so we're going to multiply both sides by A. And we're left with A tan 60 equals 70. And then we want A on its own, so we're going to divide both sides by tan 60. And we'll see the tan 60s go away, just like the A's went away here. And I rewrote it. A is equal to 70 over tan 60, and so you get A is equal to 40.4, and we got to go back to our units here. This was 70 feet along the bottom. We're using feet, so it must be 40.4 feet. Okay, so that was really important. We can right there say, therefore, the first building is 40.4 feet high. Then I'm going to look for the second building for this long piece over here from E to C. I don't have enough information. I don't have any lengths in that big monster triangle there. So I could worry about the top triangle if I want to, or I could worry about the giant triangle. But this is the only spot that I have where I've got some information about this bottom triangle. If I knew this side here, then I'll be able to figure out the rest of it. So I need to find the length AC. Okay, so still in our triangle ABC, I'm going to say, okay, still in triangle ABC, find the hypotenuse. So I just paused for a second, rewrote the exact same triangle so I don't get confused. I made sure I labeled again which is the opposite, which is hypotenuse, which is the adjacent. And then I'm going to say, okay, I really want to find that hypotenuse. So as I look at my three different formulas, hypotenuse is the one I want. And I have the angle. And I have the adjacent. And I have the opposite. So which of the three formulas do I want to use? So either the sine or cosine can work. I'm going to look back though. The adjacent one I just calculated and the opposite I had. So what if I made a mistake with the adjacent? Then my second calculations are going to go off. So I'm going to definitely choose this guy because it's the least calculated one. So I've got sine theta equals over h. Sine of 60 equals opposite is 70. Hypotenuse is unknown, so we can call it h if you like. Okay, or x if you want to. Again, it's one of those pain ones where you have to do two sets of calculations. We're going to multiply both sides by h. And we've got h sine 60 equals 70. And then we need to get h on its own. We're going to divide both sides by sine of 60. H equals, what do you get? Get 80.8. Again, it's feet. Okay. Looking back then to the original triangle, we've got that 80.8 feet. Let's redraw. Now we're going to look at triangle EAC, the big triangle EAC, and we're going to redraw that one just so we're just focused on it, okay? So EAC, look like this, approximately. Whoops. Sorry, I'll throw that back in with a nice printed one instead, okay? It would be nice that we know this is a right angle. So it would be nice to know a couple more angles. Like we could find this one out and we could find this one out. I don't know if we need them both, but why don't we go ahead and find them. So in the top triangle, in triangle AED, we know that E plus 90 plus 20 equals 180 degrees. If you want, it's a angle sum of a triangle theorem. And we can get E plus 110 equals 180. E is equal to, we're going to minus 110 from each side. E is equal to 180 minus 110 is 70 degrees. Whoops. And we could even say, so we know that's 70 now. And we could say in triangle ADC, C plus 30 plus 90 equals 180. C plus 120 equals 180. C equals 180 minus 120, because I'm going to take 120 from each side. C is equal to 60 degrees. And we should have also been able to say this 50 degrees plus 70 plus 60 better equal 180 as well. So I know this one's crazy long. So now if I got rid of that middle line here, and we just think about that triangle AEC, if that's capital A, then this side is little a. If that's capital C at the bottom, then the little side over there is capital C. If capital E is at the top, then this is little e. And now we can think about sine law or cosine law to be able to find out we really want to know little a. That's what we'd really like to know, right? So we know our formula is A over sine A equals B over sine B equals C over sine C. And what do we have? We've got capital A, we've got capital B, and we've got capital C, and we've got, sorry about that, AEC, so that should be an E, sine capital E, pardon me. Okay, and we've got little e, and we'd like to know A, so we're going to have to choose this formula. So A over sine A equals E over sine E. Before I finish this, you go ahead and pause and think what the final answer is going to be. So I want A on its own, so I'm going to multiply both sides by sine 50. They go away. I'm left with A equals 80.83 times sine 50 divided by sine 70, and I get 65.89 feet, or you could round it to 65.9 feet. This was a word question at the very beginning. Look how crazy long this building is. We need to find the two buildings and the final height. So we can say a final statement now. Therefore, for height of first building is, what do we work it out to be? 40.4 feet high. And second building is 65.9 feet high. We could have asked how much taller is the second building than the first building, in which case we'd just be worrying about the top half section there from E to D, but that works out quite well. Thanks.